Good morning, Algebra 3 students. Let's get started on our discussion of multiplying and dividing radical expressions. Remember, a radical is really just this symbol that we're used to seeing as a square root, but sometimes the indices can change, so we'll take a look at all of these things. So the first thing we need to do is remember that when we've got a minus or a plus that is in here, we need to make sure that we're going to distribute everything to everything in this. So sometimes people think about what we call the FOIL method, but as long as you make sure that you're multiplying and distributing everything in the first expression times everything in the second expression, then you're going to come out with the right answer. Now what you'll notice here is that this can't be simplified and this can't be simplified, neither can this or this, because there's no duplicates, so this one actually is finished just as it is. All right, now what we notice here is we have something special happening. This is exactly the same except one has a plus and one has a minus. So when we distribute each one of these things to each one of these things like that, okay? When we distribute, what we have happen is this one gives a negative of the same thing that this one is a positive of. This only happens when the front and the back match and there's a plus in one and there's a minus in the other. Those are called conjugates. We'll get to them a little later. But these two things will drop out. So here we have a square root of 100 and here we have a square root of 9, which gives you a final answer of just plain 7. Conjugates, this type of problem that comes out, are very useful to us. Notice that this is not that conjugate situation. In this case, those middle pieces do not drop out. Okay, these are not opposites, so there's no reason for them to cancel. When we multiply and we get the square root of 49 and minus 3 square root of 7 and minus 3 square root of 7 and plus 9, these do not drop off. We've had this special rule before, but just so you see it happening once again, this one's 7 and 9 get put together, but beyond this it can't simplify. Okay, you might, if you really wanted to, you could factor out a 2 here, but it really wouldn't do you any good and it wouldn't be really any simpler. Okay, this one, once again, you've got radicals here. The front and the back match exactly, and there's a minus and a plus, so you're anticipating the middles dropping out. When you get good at it and you always are able to recognize these patterns, then you don't even have to write those middles. We have 5 squared at the beginning, which is 25, plus 5 cube root of 3, minus 5 cube root of 3, minus the cube root of 9. Now be careful here, it's a cube root, not a square root. So even though the middles drop out, that end part does not turn into a 3 because there's only 1, 2, 3s here, 3 times 3. You need 3 of them in order to have one come out. Okay, because you're looking for what number times itself gives you this number in here, so we're missing one. So it's got to stay in. Here, once again, you have the situation, you have plus and minus of the same thing. So square root of k squared, these two match but are opposite, and then the last one, so you end up with k minus y. Alright, so this is a nice little review for you, reviewing what happens with radicals, reviewing what happens with what we call conjugates too, which we'll get to a little bit more. We know that you can't end your answer with a radical in the denominator. We've already actually reviewed this year when we were dealing with simplifying things with your trig. Okay, so this one is completely review. We're looking for another square root, so you're looking for square root of 7 over square root of 7. So that this part, when you multiply it, will cancel out. Same here, you're looking to multiply by square root of 5 over square root of 5 to get rid of this in the denominator. going a little fast since we've already done this year. You can then, after you've brought this out, so you've rationalized the denominator, always look for anything that's in common outside of the radical sign. So the 5 and the 5 can cancel, and you end up with just the square root of 10. So look for those things. This you can just directly multiply by square root of 12 over square root of 12, or you can simplify first. When it's a simple one like this, you may as well just go directly to whatever that radical is, but we'll show you when it gets more complex. It's often much better to go ahead and simplify first. So we have square root times itself gives you that number. We don't have to actually multiply these because they're the same number, so you're going to get the 12 to come out, but then look and see the 6 and the 12 will cancel. Common factor of 6 there. So 6 divided by 6 is 1. 12 divided by 6 is 2. Not done yet because the square root of 12 can get simplified. 12 is 2 times 2 times 3. There's a pair of 2's, so 1 can come out. But then once again, don't forget to look for anything that will simplify. The 2 and the 2 both have common factors of 2, so they can just simplify right out of there. Okay, so it's more complicated. All right, so here's some that are more complicated to start with. If you just start by multiplying by square root of 125 over square root of 125, you're going to make a lot of unnecessary simplifying work for yourself. So while it's all well and good where you had square root of 12 and you just save it to the end, when things start getting more complicated, simplify at the beginning so that you don't have so much complicated work at the end. So here in the first place, we can simplify. The square root of 18 is really 3 times 3 times 2. So a 3 comes out and the 2 stays in. 125 is 5 times 5 times 5. Pair of 5s, 1 comes out, 1 stays under. So now we don't have such a big thing to get rid of in the denominator. We just need to get rid of this square root of 5. So since we're just looking to get rid of a square root of 5, we don't care about this. This can stay. This has to go. You can multiply by square root of 5 over square root of 5. And then when you do that, be careful. Okay, in the numerator, you're not going to get a pair here, so you'll have the square root of 10. In the denominator, square root 5 times square root 5 is 5. Be careful with that. Don't lose it. Sometimes people have a tendency of losing it because there's this other 5 that's hanging out here, so be careful. And then simplify finally to get that last bottom denominator into 25. All right, let's review our rules here. 50 is 2 times 5 times 5. So a 5 comes out. 4 divided by 2 gives you 2. So you've got a 5m squared that comes out and a leftover square root of 2 that stays in. For here, 5 divided by 2 gives you 2 that comes out and 1 that stays in. So here's our simplified form of our fraction before we even begin to deal with getting a radical out of the denominator. And because we have all products, this is why we can do this so easily. You need another p here to make p squared, so we need to do square root p over square root p. This turns into a p. This just comes together. And then with the p cubed in the denominator, just to simplify it down just a little bit more. All right, now we're assuming that all these variables are positive, by the way, so we're ignoring those absolute value technicalities, because if this wasn't positive to start with, we wouldn't be able to even do this problem. So we can do that. All right, so moving along here, cube roots. Cube roots have their own challenges because we need to remember we're looking for groups of 3 rather than groups of 2. So when we first begin to simplify it, this one, 2 times 2 times 2 times 2, 3 would be able to come out, and then 1 would be left over inside, and the cube root of 27 is just 3. Now, here's the thing with this, though. We aren't just looking for one more 2 to be under this radical. Okay. We're looking for how many 2's it's going to take to make this a complete group of 3. So we'll need 2 more of those 2's to make a group of 3. Well, what does that mean? That means that we're multiplying by the cube root. Here's my 2 more 2's. Here's my 2 more 2's. This is just 1. Anything over itself is 1, so we're multiplying times 1, so that works. The reason we do that is because here we have the cube root of 8, which is just a 2. Cube root of 8, there's 3 2's now, which will give us a 2. This part can't get simplified anymore because we don't have a group of 3. We don't care about the numerator. So here's this 2, don't lose it. Here's these, which turn into just 1 because it 1, 2, because of being 3 of the same thing. And we can simplify that. Now just be careful, don't be tempted to try to cancel this one and this one. A 4 is different than a cube root of 4. They're 2 different numbers. They don't have a common factor. Okay, they just look enough alike that it's tempting to try and slash them, but they're 2 completely different numbers. Be careful with them. All right, 4th root, same type of thing. It's something else to deal with. This is a z, not a 2. Okay, so we'll break it down into numerator and denominator. And what we notice here is we have 1z, but in order to get rid of the radical, you need to have a group of 4 of them. So we need how many more? We need 3 more. So we need 3 more z's and 3 more z's. This is okay to multiply by because anything over itself is just a big old 1. So now we have 4 in the denominator, which means that this will turn into just a z. Nothing up here will simplify, but they can go under the same radical. And then we've got this. This one is not so bad. And this is also a z, not a 2. Okay. Now, back to our conjugates that I mentioned earlier. Conjugates are important because we need to be able to rationalize denominators that have sums involved in them. So let's go back to this, and reviewing a conjugate is just the same beginning and same end with an opposite sign put in the middle. So here we have these, and if you want the conjugate, just put a minus in the middle instead of a plus. Here you've got a minus, turn it into a plus, and all of a sudden you've got the conjugates. Okay, so this would be 1 minus square root of 6, 9 plus square root of 2. They're the conjugates. They're useful because when you multiply a number and its conjugate, those middles drop out, just like when we showed in the earlier examples. So when we're going to simplify a binomial, simplify a fraction with a binomial in the denominator, what we need to do is we need to make sure that we're multiplying that denominator by its conjugate in order to make the radical go away. Okay, so here's what happens with that. 4 plus square root of 3 is the conjugate of the denominator. You're always just looking at the denominator to cancel out in order to rationalize it. We don't really care about the numerator. So when we do this, the middles will drop and you'll end up with a nice integer in the denominator. You have to do numerator and denominator, so you're just multiplying by a fancy form of 1. Okay, so numerator gets distributed. Denominator, 4 is times 4 is 16. Those middles, I have them written in here for you to show you one more time that they'll disappear. Plus 4 square root of 3 minus 4 square root of 3 minus the square root of 9. So our result is that these two are gone, and you're just left with 16 minus 3 in the denominator, which gives you 13. It can't simplify any further. There's nothing in common here. But now you can kind of see the point of having a conjugate, and when you are very confident of it, and in the next example I'm going to show I don't even have to write these because I know that the whole point of using a conjugate is that the middles are gone. I don't have to write them. I don't have to think about them. I do have to be careful that I remember to put a minus in the middle, and I do have to be careful of what happens with my numbers, but the middles, I don't have to worry about them at all. I don't even have to write them. Okay, so let's think about here. You're looking for conjugate of the denominator. I do have radicals in the numerator. I don't care about them. But to find what I need to multiply by, I have to find the conjugate of the denominator. Here's my conjugate of my denominator. Then multiply. This one has a little bit more as far as the multiplying in the numerator goes. Okay. Here it is. Here's our 10 and our minus square root 6 and our minus square root 15 and our plus minus negative makes a plus 3. Our denominators, I wouldn't have to write them, but there they are just in case you need to see them. 5 at the beginning minus 3 at the end. None of this will simplify. Each one of these radicals, this is a 2 and 5, nothing comes out. This is a 2 and 3, nothing comes out. This is a 3 and 5, nothing comes out. They can't get put together. You can only scoop them under the same radical if it's multiplication or division. That's not the case, so that one's done. Okay. This one, look at your denominator. Determine the conjugate. Change the minus into a plus. Distribute your numerator and your denominator. Aha, this time I didn't write it, did I? Didn't write it because we want to get good at it so you don't have to write those middles. Square root times itself gives you that number. Minus, because the middle parts have completely dropped out because we used conjugates correctly. And then square root times itself turns into that number, so you can be done with that. This I distributed to both of these. Nothing can cancel out. This one's tempting, but it's part of a sum, and also the square root of p is different than just a p. Same here with the 5m. It looks tempting, but it's really not the same number at all. And you have a sum, so you can't just take a part of a sum and cancel it out. So this is your simplified form on that one. All right, this one doesn't have anything in the denominator to be concerned about. However, what we can do is we can look for common factors in the numerator that can help you to simplify. So don't forget about those type of things. So for example, 2 is a common factor here. So you can do this 2 times 3 plus square root 5 over 4. And now, since you have a product, this is where you're allowed to cancel out. You can't cancel out just one piece. You have to cancel out a common factor. So in order to cancel, you've got to factor first, then you can cancel. Okay? Factoring and canceling can happen. Canceling just one of these gives you a different number because this 4 is part of both of these numbers here. Okay? So here's our final answer. Over here, we might want to try to factor first, but there's nothing in common here and here yet. That's nothing that's obvious. So what you need to do is you need to make sure that you simplify this first. 2 times 2 times 2, okay, means a 2 comes out and a y also comes out. And that's over 6y. In the numerator, the common factor is a y, so we can bring that out to the front. And then the y is allowed to cancel with the y in the denominator, giving you 5 minus 2 square root of 2 over 6. Completely simplified, no variable left in that. So you look for factors. If there aren't any, you should simplify, and then some might pop out for you. All right, so lots of things to think about, things to practice. You've seen it before, but we're trying to brush up those skills for you, those that are heading to college and your college entrance exams. I want you to be as well prepared as possible. Those of you that are heading into your next math and taking SATs and placement exams next year, we want this to be as familiar as possible to you. So this is a great thing for us to be working on right now. Okay, that's about all I've got for you today. Have a great day, and God bless you.